So here we'll be looking at limits and continuity. So there's a couple of definitions to keep in mind. Firstly, a function is continuous at x is equal to a if the limit of f of x as x approaches a is equal to the function value of f at a. And the second definition to remember is that a function is continuous on an interval ab if it is continuous at every point in the interval. Another thing to note is that if a function is continuous at x is equal to a, then the function value f at a will be equal to the limit as x approaches a of f of x. And this will also be equal to the limit as x approaches a from the left side of f of x, and will also be equal to the limit as x approaches a from the right side of f of x. And if we look at that graphically, on the right-hand side here, we'll see that this function value of f of x in yellow is equal to the same value as x approaches a from the negative side, and the same as x approaches a from the positive side, and in turn the same value as the full limit x approaches a. Here we'll just look at a quick example. So if we look at x is equal to a here, we see that the function value falls around that region, but we know that the limit from the left side will be equal to the function value, but the limit from the right side will not. So at x is equal to a, there is a discontinuity. At x is equal to b, we see that the function value is equal to the limit on the left side, the limit on the right side, and the limit of the whole function. At x is equal to c, the function value is not equal to the limit on the right side or the limit on the left side, or the limit in general. So there is a discontinuity at c as well. So here the only points that are continuous is at x is equal to b. Now if we look at a proper example, we can see that if we have f of x is equal to x squared minus 4, and say we want to find if this function is continuous at x is equal to 3. So the first thing to do is to look at the function value at x is equal to 3. And this will be equal to 3 squared, which is 9, minus 4, which will be equal to 5, as shown on the graph. And we know the limit from the right side, approaching x is equal to 3, will also be equal to 5. And similarly on the left side, will be equal to 5. And from these two, we can also see that the limit as x approaches 3 will be equal to 5. And now we can conclude that at x is equal to 3, f of x equal to x squared minus 4 is continuous.